Over a review of the anatomy and physiology of the skeletal system, which is Module 1 of the skeletal system. It should be somewhat of a review for you since we went over a lot of this stuff in the positioning courses. So we're going to start with the objectives for this module, and we're going to go over the classifications of the skeleton and joints in the body. We're going to go over the types of bones in the body, and then we're going to go through the structure, the physiology, and function of bones, joints, in the skeletal system. So we're going to start with the skeletal classification. The skeletal system is composed of 206 bones and is divided into the axial skeleton and the appendicular skeleton. The axial skeleton contains 80 bones, which you can see here in this picture. It includes the skull, the spine, the ribs, and the sternum. For the appendicular skeleton, it contains 126 bones, and that includes, as you can see here in this picture, the extremities, the pectoral, and the pelvic bones. Okay, so next we're going to go and review on joint classification, and they are classified functionally and structurally. There are three types functionally, which are synarthroidal, amphiarthroidal, and diarthroidal. So we're going to start with the synarthroidal, and they are immovable joints, and they have a layer of fibrous tissue in between the bones. Then as the tissue actually atrophies and disappears, the bone ends then fuse together. An example of this is the skull with the suture bones. The next type, the amphiarthroidal, these are a mouthful, which are slightly movable joints. They have a layer of cartilage on them though on both ends. And an example of this would be the intervertebral joint spaces that actually have like the cartilage inside of the joint space. The last type of functional joints, which is known as the diarthroidal, they are freely movable joints, and that's due to a space between the ends of the bones. So they are just freely movable. So now we're going to move on to the structurally joint classifications, and those are known as gliding, hinge, condylar, saddle, pivot, and ball and socket. We're going to start with the gliding joints, and they're also known as plane joints, and they have plane flat surfaces and they glide over each other, hence the name gliding joints. And an example of that would be the vertebrae. A hinge joint is, they actually allow angular motion in only one direction though, like a hinge on a door. An example of a hinge joint would be your elbow joint. The next type, the condylar, which are also known as ellipsoidal, they have what is called a head-shaped bone, and that fits into an actual concave surface, which allows the motion of flexion, extension, abduction, adduction, and circumduction. So an example of that type of joint would be your wrist joint, because you can move it pretty much freely all over the place. So that would be what is known as a condylar joint. Now the next joint, which is a saddle joint, it's similar to the condylar joint, except that one end of the bone is convex while the other is concave. And the only saddle joint in the human body is the thumb. Now the next joint, the pivot joint, it allows rotation to occur by being kept in place by a ring of cartilage or bone, which is around the head of another bone. An example of this would be the joint of C1 and C2. And the last type of structural joint is the ball and socket, and they have a head-shaped bone end that fits into an actual cup-shaped socket, and an example of that would be the hip or the shoulder joints. Okay, so those are all the type of joint classifications. Now we're going to move on to the different types of bones. And there are 5 types of bones. There are long bones, short bones, flat bones, irregular bones, and sesamoid bones, which we reviewed all of those in the positioning class. The example of a long bone would be the tibia or your humerus or your femur. A short bone would be a phalanx. A flat bone, like we said before, would be your skull bones. An irregular bone would be a type of bone that would be in your foot, and a sesamoid bone is like a free-floating bone, which would be your patella or underneath your great toe. There's also a sesamoid bone. Okay, so now we've gone over all the different types and classifications of bones and joints. We're going to go over the actual structure of the bone. And almost all bones are with 2 layers of what is called periosteum, which you can see here in this picture, which is right here. Okay, the outer layer is actually made up of dense fibrous tissue, and then the inner layer is made up of cells called osteoblasts. So the periosteum is made up of 2 layers. Okay, and they actually help with the bone production. And then the next layer beneath the periosteum is what's called the cortical or compact bone, which you can see is right here. And it's a dense type bone. Okay, then the next layer, which is known as the spongy or cancellous bone, and it appears like honeycomb. So you can see it here in this picture better. It has like a honeycomb type appearance to it. And the open canal that runs down the center of the diaphysis of the bone, which you can see here in this picture, and you can also see here. It is actually known as the medullary or the marrow cavity, and it contains bone marrow. You can see here, this is actually bone marrow here, but it's called the yellow bone marrow, which I'm going to go over here in just a few minutes. Which I'm actually going to go over that now. So the yellow bone marrow actually contains predominantly fat, and it's found, like I said, in the marrow cavity. And the other type here, which you can see, is known as the red bone marrow, and it's what forms the red blood cells, and it's found in the open areas of the spongy bone. So it'll be found up in this area here. Okay. Okay, so we went over the entire bone structure there. Now we're going to go over how the bone actually forms in that structure to become that bone, the mature bone. Okay, so it starts out first here as what is known as a hyaline cartilage model. Then the cartilage starts to calcify, as you can see here, and it forms what is called a bone collar around the cartilage. Okay, then it forms what is known as a primary ossification center, which you can see here. Okay, and that actually is where it starts to form the diaphysis of the bone there inside there. It actually takes the replaces the cartilage with bone in this area here is where it starts. But this is the primary ossification here, and then it will move on to what is called a secondary ossification center, which is formed, and that's where the bone actually starts to replace the cartilage. But the bone doesn't replace what is known as the articular cartilage or the epiphyseal plates, which are also known as growth plates. And then lastly, on this picture here, that's where the actual epiphyseal plates or the growth plates ossify and form what is called epiphyseal lines, which starts to form into a mature bone. So you can actually see kind of like the growth plates here, which are the epiphyseal line here, and those will start to go away as the lines form up through them, and that's when you get a mature bone, and then you can no longer see them. Okay, so now we're going to go over the skeletal system functions. Because of the bones that we went over, this is how they actually help the system function. And there are 5 ways within the human body. And they function with support, protection, movement, production of blood cells, and storage. Okay, they provide support to the body and the surrounding tissue. And the skeletal system also provides protection to the organs inside the body. So if you have any kind of trauma, it'll protect the organs inside, and it'll give more impact to the bone instead of to the organ inside. And the way it provides movement is when the actual muscle contracts, it moves the bone. Then after the muscle contracts, helps move the bone. And it produces new blood cells, like we said before, by the red bone marrow that's inside the bone. And it also provides storage of phosphorus and calcium, and that's why they tell you to drink lots of calcium, eat lots of like cheese and drink milk and stuff like that to help provide for that storage in your bones for the calcium. Okay, so this actually concludes the overview of the skeletal system anatomy and physiology, and so we will go on to the next module, which goes more into the pathology of the skeletal system.